Hello everyone, I hope by now you have learnt hydrocarbons well. So now in this video I will be discussing conversions, which is a very important part of organic chemistry. So if you have practiced all the reactions of hydrocarbons thoroughly, then you will be able to do the conversions well. And these are very important questions, conversions. So first one is ethane to methane. If you have to convert ethane to methane, how are you going to answer that? You will write here CH3, CH3, ethane. You have to decrease one carbon atom. Remember one thing, to decrease one carbon atom, we have to make use of decarboxylation. So first, we should be coming up to acid of it. That means we have to oxidize this to get 2 carbon acid, that is ethanoic acid. So to get that, we carry out its oxidation in the presence of manganese acetate. You will get this ethanoic acid. Now this ethanoic acid you will have to treat with sodium. When you treat this with sodium, you will get sodium salt here. That means you will be getting here CH3COONA. I'm just writing the product this side. Sodium acetate you will get. Now, from this, you can very much easily prepare methane. What you have to do is, you have to carry out the reaction with soda lime. Soda lime is NaOH. Lime is CaO. You will get decarboxylation. That means 1 carbon atom less will be obtained, that is methane is obtained. Right? So if you have to decrease the carbon atoms, you will remember decarboxylation. So to get that, we have to first convert ethane to acid, acid to the sodium salt, and then soda lime. So this is how you will be writing the conversions. Now the next is methane to ethane. You have to increase the carbon atom. Here it was 2 carbon becoming 1. Now 1 is becoming 2. So you remember Woods reaction in this. So what you do is, you will take methane. You will react methane first with limited quantity of chlorine. In the presence of sunlight, the reaction will occur. And then it will form methyl chloride. Methyl chloride. Now 2 methyl chlorides, you will react it with sodium. In the presence of dry ether. In the presence of dry ether, so this part will come out as sodium chloride, and you will have ethane. You will have ethane here. Right? Now, at times in the same question you are asked like that. How will you convert methane to ethanoic acid? Suppose you are asked convert methane to ethanoic acid. Ethanoic acid. Instead of asking ethane, suppose ethanoic acid is asked. So till here it will be same. And then from ethane you have to prepare ethanoic acid. That means by this method. So what you will do, you will add one more step in this. Carry out reaction in the presence of manganese acetate. And when you do that, what you get is ethanoic acid. So remember what is given in the question. Accordingly you will use it. Here. Now, moving on to the next conversion, which says that how will you convert propine to propanone? Propine to one. What reaction you have studied in class 11 regarding alkyne to that ketone or some carbonyl compound? You have that addition of water. So what you will do is propine, you will add water. You will add water, and this is done in the presence of acid medium HgSO4, H2SO4, HgSO4 60 degrees Celsius. So since it is unsymmetrical alkyne, you will be adding water as per Markovnikov's rule. H this side and OH this side. So you will have OH attached here. So the first product, I'm just writing it down. So you will get the first product as CH3, COH. This becomes a double bond, and CH2. Now in this there is tautomerism. This is enol, isomerism, it undergoes. This H goes this side and O comes this side. So what you get is the rearranged product. So you will write down here, this undergoes tautomerism, rearrangement. On undergoing rearrangement, it will result in the formation of acetone. Propanone, the other name for propanone is acetone. At times you are asked, how will you convert propine to acetone? So you will be writing this equation. Got it? The other name for propanone is acetone, the common name. Next, tertiary butyl bromide to isobutyl. First of all, you should know the structure of tertiary butyl and isobutyl. Tertiary butyl means bromine is attached to tertiary carbon atom and that radical is having 4 carbon atom. That is tertiary butyl. You need to prepare isobutyl. Isobutyl means 3 carbon, 1 branch and then 1 bromine here. You want to prepare this way. So what you need to do is, you'll have to remove bromine from here and you have to put it here on the terminal side. So quite simple. You first carry out reaction in the presence of alcoholic KOH. It is actually H3, H3, H3. So it will carry out dehydrohalogenation. Br and H will be removed from here. So what you will get is this CH3 here. This will be a double bond. And just one second, this is Br, let it be this as Br only, and 1 Br, and this is a double bond. This is what you get it, 1 Br from here and 1 H from here, so this becomes a double bond. Now you want one second, this Br has to be removed from here. Yes, this was alcoholic KOH. You have to carry out dehydrohalogenation. So 1 H and 1 Br will be removed. This is what you will get. You will get alkene. Now we want to add HBr to it. Again, Br should be this side. That means against Markovnikov you are adding. So what you will do is, you will be carrying out the reaction with HBr in the presence of peroxide. In the presence of peroxide. So H will add here, Br will add here. So this will be the product. This was our desired reaction. But this is how you will go. You will go this way. This is H3, this is H3, this is H2, and this is H. This is isobutyl bromide. Tertiary butyl bromide, alcoholic KOH. First you remove Br and H. You will get this, and then against Markovnikov you want to add that HBr. So in the presence of peroxide you will get this. Suppose the question is asked, how will you convert isobutyl to tertiary butyl? Reverse. You will be first removing HBr. You will get a double bond here, and then Markovnikov addition will be there. To convert iso to tertiary, first step is same. In the second step, you will be carrying out Markovnikov addition of HBr. Clear? Now moving on to the next conversion. 1 chloropropane to 2 chloropropane. 1 chloro. I am just drawing the carbon skeleton. I think that is enough to understand. 1 chloro you want to convert to 2 chloro. The procedure is somewhat like what I have discussed now. You will first carry out reaction with alcoholic KOH. So you will get, a double bond here. Now you want a 2 position Cl. That means to this you will add HCl in the Markovnikov addition, Markovnikov's rule. So you will get Cl here at the center carbon atom. Now if you want, you can just complete these valencies. Since now you have learned these reactions, I think this part you can manage. If you want Cl at one position, then we will have to carry out anti-Markovnikov. So in this case, that is in the second case, what you do is, the first step remains same, carry out with alcoholic KOH. You will have CH3, CH double bond CH2. Now you want Cl at one position. No, in this case it cannot be with this thing Markovnikov. We will have to replace this chlorine with bromine. This has to be bromo then. It cannot be chloro. You have to change the question. This has to be bromo. Bromo. Please make that correction. This will be bromo. Okay. So first step is, this is Br. You are removing it. You are getting a double bond. And then HBr will be added in the presence of peroxide. Why did I make this correction? Because HBr addition only, that anti-Markovnikov rule is applicable. So now it will add on as per anti-Markovnikov rule. You will have CH3, CH2, CH2, Br. Here it was fine. Here whether it is chlorine or bromine, this is fine. In this case it was not fine. So I hope this part you have corrected. It is bromo. 2 bromopropane to 1 bromopropane. If it is 1 bromo to 2 bromo, then it will be the same method like chlorine. But this is possible only for Br because anti-Markovnikov rule is not applicable for HCl or HI. Those reasons we have already discussed earlier. Okay. Now moving on to some more conversions. Suppose you are asked like this, ethane, you have to convert to some benzene like products. This to para-chloronitrobenzene, meta-chloronitrobenzene, para-nitrotoluene. You have to see the product, the structure of the product first. This is benzene. You want here para position pe. You want chlorine and nitro at para positions. In this case, you want chlorine and nitro at meta position. Say chlorine is here, nitro will be here. In this case, you want here CH3 and nitro group at para positions. So what you have to do in this, the first step is fine. You will have to carry out the reaction with a red hot iron tube. You have to pass that ethane through that, and the first step is you'll get benzene. Now you have to go to prepare these. You have to keep in mind the two side groups are at para position or meta position. If they are at para position, then you will have to carry out first that reaction in which the group is ortho-para-directing. That means if this benzene I want to prepare this one, you want the two at para position, that means I have to carry out chlorination first. The first step will be add chlorine in the presence of anhydrous AlCl3. So first you will get chlorine introduced. Then in this moment chlorine will be introduced. After that you will carry out the reaction with H2SO4 HNO3. Then you will get the nitro group introduced at the para position. In case you want the two at the meta position, then you will carry out reverse. First nitro is to be introduced because you want both at meta position. The meta directing group is to be introduced first. So you will carry out the reaction with HNO3, H2SO4 first, and then you will carry out the reaction with chlorine in the presence of anhydrous aluminium chloride. Clear? And para-nitrotoluene means you will have to first carry out the reaction with methyl chloride in the presence of anhydrous aluminium chloride. You will first prepare toluene, and after toluene you will carry out nitration HNO3 and H2SO4 so that you get that para-nitro-toluene product. Got it? Till here I think conversions are clear. So these, though there are many such conversions possible, but I am discussing few so that you have an idea how to go ahead with the conversions, how to write them in the paper. Okay. Now suppose you have some questions like this, ABCD type. Some calcium oxide is given. These are some examples. With carbon it is forming this, further with water, B, red hot iron tube, C, then this B again with sodium form D. In this, one clue will be somewhere to go ahead, to proceed with, to start with the reaction. Like here there is one clue. Sodium benzoate. What is sodium benzoate? Sodium benzoate is C6H5 COONA. Sodium benzoate. Sodium benzoate, when you carry out the reaction with soda lime, decarboxylation will occur. That means this product we found. So somewhere there will be a starting point, and from there you have to begin. So you got this benzene. Now when you got this benzene, you got a clue that this should be ethine then. So that with red hot iron tube you are getting, so this is ethine. You got that clue that this is ethine. Now ethine, can be prepared like with calcium reactant. If you remember, in the preparations we have done calcium carbide. Calcium carbide, if you carry out the hydrolysis, you will get ethine. So this is how it is. Now A is this, B is ethine, C is benzene, and what is D? This ethine, when it is treated with one equivalent sodium, means only one sodium. So one side H will be replaced by sodium. This is a very important test, to prove that ethine is acidic in nature. It is given only by terminal alkynes. Okay. Now, one more such conversion, I am taking. Say you have this is butene. You are carrying out the reaction with, this is the starting point. Wherever some reactant is given or the product is given, one of it will be given, molecular formula will be given to proceed. So this, when you are carrying out the reaction with bromine and carbon tetrachloride, of course this has to be added, Br will be added. So what you will get? You will get like this, and you will have one Br attached here, one Br will be attached here. So you will get two bromines attached. That means 2,3-dibromobutane is obtained. Now with alcoholic KOH and this NaNH2, what you get is, you get a triple bond here. That means you will get but2ine. You will get a triple bond. Both the Brs have to be removed. Alcoholic KOH will remove Br and H, another NaNH2 also. You will get this butane. Instead of writing this way, you may also, open up the structure and write this way. CH3C, triple bond C, CH3. Now this is some alkyne which is treated with red hot iron tube. We have done in the class with ethine. If you use any other alkyne, also you will get a benzene-like structure. But only thing is, what about these extra alkyl groups? There are alkyl groups on both the sides. That means 3 of them have to. 3 such molecules will trimerize with red hot iron tube. So that means benzene will be formed. But apart from that, there are 2 methyls present on every both the carbon atom. That means every carbon atom here will get 1 methyl. So it will be 1, 2, 3, 4, 5, 6 hexamethyl and benzene. All H will be replaced by this. Okay. So you will get this as C. Then they are saying this butane, when you are treating with HgSO4 and H2SO4, then what will be obtained? That means to this you will have to add water and C. What you will get? This is there and you are adding water to it. It's a symmetrical one. So H and OH will be added on. Okay. So what you will get is, this will be added on and you will have CH3, C, this is here H, this becomes a double bond, this is COH and this is CH3. Okay. So after this is formed also there will be rearrangement. So what will happen is, this H will go this side and a double bond will come here. So the product here will be CH3, this will be CH, this will be CH2 and this will be CO and CH3. This will be the product. Now one more clue is given, that B is again treated with this sodium liquid ammonia and you are getting this alkene. And we know that with this you get trans product. You get the trans product. Okay, that means you will have this carbon-carbon double bond. You will have here that CH3 and this will be H. This will be CH3 and this will be H. That means you will get alkene. You remember that if it is palladium and carbon, what you get is a cis product, and with sodium liquid ammonia you get the trans product. Anyway, now ozonolysis. For ozonolysis it is very simple. This bond has to break. You have to add O the either side. When you add O the either side, what you are getting here? You are getting here 2 molecules of CH3CHO. 2 molecules of CH3CHOs are obtained. I hope now it is clear. So you can practice the questions based on the conversions. But before practicing the conversions and ABCD type of questions, please learn all the reactions of hydrocarbons so that you are able to do these thoroughly. Okay, and distinguish between questions are also very important. Okay, thank you. Prepare well for exam.